Hello, today I'm going to walk you through how to complete the in-class data synthesis activity. We're going to start on the FRI Semester 1 Brightspace. You can see that view here, and go to the Assignments tab, and then look for the in-class Excel homework. Here we can see the pre-class Excel synthesis activity with some of the basic instructions, and most importantly, all the attachments that you will need to do the pre-class work and in-class work. You need to make sure you download all three of these article PDFs in order to see the highlighting that we have placed on these files, and you need to download this Excel file as well. Once we have downloaded the Excel file and the article PDFs to our computer, we want to open that file in Excel. For those of you who have Microsoft Office installed on your computer, as I do, you would just open Excel and open the download there. If you are working from a computer that does not currently have it installed, you can log into Microsoft 365 online using your Binghamton credentials and the same email and password information you would use to log into Brightspace, and we can work on Excel from our web browser as well. So we can upload the file that we just downloaded. And it's thinking, and that will take us here to Excel. I'm going to work in the online version of Microsoft 365 for those students who don't have it installed, but it looks quite similar if you are using your downloaded and installed version. You would have completed reading these articles and answering these questions before coming to class today to carry out the in-class synthesis activity. So hopefully this would all be filled out and you would have a decent idea of what is going on in each of these articles and how they're similar and different in their analyses and findings. I am going to take us to the in-class tab of this workbook so that we can complete this data synthesis together if you did not have time to finish this in class with your teammates and peer mentor. You'll see that the table that we've started here for you reminds you the important figures and where to find the data in these papers. And it also talks about the different scales for each of these papers. They're all looking at different impacts of AI on writing, on productivity, on learning math, skill building of those sorts. And they each use different measures to assess the impact. One is a Likert-based rubric essay score. You can score 1 to 5 on the essay, and it reports a score on that range. The other is kind of a similar score of 1 to 7, putting a score on that range. But if we had a range of 1 to 5 and 1 to 7, we can't just directly use those numbers. So we need to synthesize and put these data in a form where we can look at them side by side. And in our third paper, they're using regression adjusted normalized exam performance scores, which we will talk through and show how we're going to turn that into usable data that we can get everything in the same units, percent change, and create a graph. I am going to bring up my Adobe files right next to it so we can kind of see everything together. So I'm going to start with the basic article. It's telling us figure 1A and the text are where we're going to find the information about these impacts. Here we find figure 1, panel A, outlined here in yellow. If we want to get this essay score from 1 to 5 from just figure 1A alone, we would have to look at this dark black bar and kind of estimate what the scores would be by kind of going over to the y-axis. Many times papers will also report the exact number on the figure itself or somewhere in the text, so we always want to try to find that number rather than just kind of estimating it by eye. Luckily in this paper, we see in the text right below figure 1 the actual reported numbers for the control, 2.39, and the test or treatment group, which in our case is going to be the groups that used some form of AI, whether it was ChatGPT or otherwise, they had a score of 2. So we're just going to type in those numbers. Again, the control mean was 2.39 and the treatment mean was 2.00. Percent change is calculated by subtracting the control score from the treatment score and dividing by the control score. In Excel, we can have it do math and enter formulas for us. So this is what we want you to learn and skill build on with this activity rather than just typing this math into your calculator and entering a value in this cell. We're going to open this and make sure that you're learning how to use formulas properly. To enter a formula in Excel, we hit equals. That tells it that we are about to start typing a formula. Because we need to do a subtraction before division, and orders of operation tells us differently, we need to indicate the first component in parentheses so that it does the subtraction before the division. Again, we want to subtract we want to take the test or treatment minus the control. Again, we want to do that first, so we're putting it in parentheses and we're dividing by the control. I can either click on these cells to tell it what cell, or I could type E2 and D2. When I'm happy with the way that the formula looks, subtract these things and then divide. I hit enter and it does the math. This right now is not displayed as a percentage. I can change that in 2 ways. I could enter times 100 into my formula to turn it into a percent. That's one way of doing it. Or I can go up here to my number formatting and tell Excel that this is a percent, in which case it will change the way the cell is showing that number. Either option can work for you. So we've gotten our data from the basic article. We will next go to the Noy and Zhang productivity article. This tells us that the data are in figure 1D. I'm already on the page with figure 1, and we can see panel D here. Once again, we could be looking for estimating these mean grades, but they are actually reported here, the exact numbers in the top right corner of figure 1 panel D. So we can steal those numbers and type them into our Excel sheet. Control 3.802 and treatment mean 4.53. Once again, we're going to turn this into a percent change so that we can compare these scores. They're scored on different scales, so we can't just graph these numbers. We have to put them in similar units. In this case, we're going to percent change. I can once again type in that formula, our test minus our control divided by the control. Yep, I can do that. And then I could go ahead and change the percentage, or I could multiply with the asterisk by 100 and get that. But even easier, another trick to learn in Excel, once you have a formula and you want to apply that same math across a matrix, you can hover in this lower right-hand corner and you can click and drag your formula down. It drags the formula and it drags the formatting of the cell. To double check that it did it correctly, you can double click on the cell and see that the math is doing what you had hoped that it would do. Super easy. Especially when you have very long and complicated formulas that you're using, having the ability to kind of copy them, click and drag is a very nice feature. Last but not least, that brings us to the Bastani article. And this one is last because it has a little bit of a wrinkled complication in the data. We can find these data in table 1 that you see here on the right hand side of my screen. But it's important to note, we can see this from the methods and the descriptions for this table, that these data, the number that's reported here is not a mean. It's this adjusted score. It also has adjustments in there for making sure that the students in each of these groups, the treatments and the controls, are of similar backgrounds, so similar GPA, similar course history. It also adjusts for the grader and instructor differences, so if one grader was harsher than another, or one instructor had more office hours than another, etc. It's kind of accounting for that as well, so that the effects that we see are, as much as they can be, controlled to just the variable of using or not using AI. So when we look at the GPT base, which for this paper is our treatment group, and we look at the exam performance score, it says negative 0.054. After everything I described there, the way that we want to interpret that is that this GPT group scored 5.4 percentage points less on the exam than the control group. Okay, so this is not the mean score. It tells us how many percentage points more or less they scored compared to the control. Our control mean is directly reported down here. So we can actually type this directly into our cell, 0.321. Again, on a scale of 0 to 1, the control group scored 32%, or 0.32. To figure out what the treatment mean actually was, we need to do a little bit of math in this situation. Like I said, the number up here tells us that this group scored 5.4 percentage points lower than the control group. If we know that the control group scored 0.321, we just are going to subtract. We just are going to subtract these scores. This gives us the mean score for the treatment group, the group that used AI. Now that we've got these mean values instead of just the regression normalized exam score performance, we can once again calculate our percent change. Again, we can do that by typing into the formula, or we can click and drag with our handy new trick. Great. We've got all of our percent changes calculated, and we are ready to present this data as a graph. I'm going to highlight the values that I want to graph, and I'm going to insert chart, a column chart. There we go. We're not going to use a chart title, so I'm going to delete that, because in papers our titles are typically listed in the figure caption or figure legend. So that's part of your homework to complete the assignment, is to write a descriptive title that tells the reader what this figure is about, and descriptive text that would allow the reader to interpret and understand the experiment and the analysis and what was done. The goal for the figure, along with its corresponding figure caption, is for it to stand alone. If someone were to come across the figure and the figure caption or legend without reading the rest of the paper, they would be able to understand it. Yes, they may need to see the paper for more details, but typically we want these to be stand-alone. Because we have positive and negative values here, we're going to want to move these axes labels and actually get these axes labels working for us. If we double click on any of the features of the graph, it brings us to this formatting pane, which is really nice. We're looking at formatting for the horizontal axis at the moment. And if we scroll down, we want to tell it where to put the labels for the x-axis. Right now they are next to the axis, but we actually want them to be low so that they show up underneath our graph. Actually, also do not need that series label, but we do need to tell our Excel what to call each of these three things. Right click on our graph and we go to select data. We come to this setup and we want to tell it what our horizontal axes labels should be. So we can click add field, add new field, and we're going to tell it these are the corresponding labels for the data points that we made on the graph at the right. Hit this check mark. Now we can see below our figure, it tells us which paper each of these was from. Some other housekeeping notes. Usually we really like to make our X and Y axes bold and stand out, and in this case the X line is in light gray, and so we want to change that to black, and the y-axis actually doesn't have a line, so we want to make sure that we get a line. Now we can see our X and Y axes very clearly, and we can leave the minor horizontal lines in light gray. We do want to make some adjustments on the y-axis, namely we want to add a title. To add axes titles in the online version of Excel, we can see that up here. If you ever can't find something, use your search function or search in Google. We want to add a primary vertical title, and we want this to read percent change in performance and indicate our units are percentage points. And now we can see that on edge. The other thing we could do here is change how many decimal places. That our axis is showing, to just clean it up a little bit more. So that is how to conduct your data synthesis. You should have your labels kind of looking like they are here. Fill out a descriptive title and descriptive figure legend. And then for the remainder of your homework, you're going to go to the third tab of this worksheet and answer these questions based on the graph that you created in class. Reach out to your research educators and peer mentors. If you get stuck on any part of this assignment, they would be most happy to help you complete your work.